So, what are the odds that a given homeowner client needs AeroSeal? Here's what the Department of Energy's chief architect, Sam Rashkin, had to say. Since well over 95% of older homes have leaky ducts, it's something that's relevant for almost everybody. Here's what I've learned the hard way, though. Even though the authorities say duct leakage is the norm and that 19 out of 20 homes have ducts that need sealing, it seems most people hope their home is the 1 out of 20 that's okay. I found most homeowners need to see at least some evidence their ducts leak before they'll step up and invest in AeroSeal. The minimum is to just show them some gaps and holes, either in person or with pictures. Next up is to make the leaking air visible using a handheld fog puffer. In this 3-part mini-series, we'll dive deeper into how to use thermal imaging, also known as infrared, to make the invisible visible. I've been using thermal imaging for over 40 years, and I'll share 20 solid tips to help you get the most from this powerful diagnostic and educational tactic. The 16 in the first 2 lessons are more technical, and the last 4 in part 3 are more along the lines of sales communication. All that when we get back. This 3-part lesson is a continuation of a lesson in Section 3 called Duct Leakage Demonstration Tool Overview. If you skip that one, I suggest you watch it first. In that lesson, we explained the 4 form factor options for thermal imaging units. To summarize, here's our tip number 1, and that is get the right imager. I have 2 recommendations. 1, if a lot of your ductwork's in attics and crawl spaces, do not skimp. Invest about $700 and get the FLIR C5 or whatever its current similar model is in their product line as you view this lesson. You won't regret it. It will take very persuasive pictures and you'll actually use it because it is much more efficient to use than the other options. Time is money, and so you will sell more seals. Recommendation 2 is that if most of your duct systems are in basements and you only occasionally inspect ducts in attics or crawl spaces, or if your budget is simply very limited, you can save some money up front by going with one of the units that plugs into your phone. My current preference is the FLIR 1 Pro model for about $375, but even the low-res $200 model is better than nothing. Be sure to also get a chest pack to make it easier to move around in attics and crawl spaces. Tip number 2 is always charge the battery between calls. Take it from me, there's nothing worse than being at the far end of an attic or crawl space with a great duct leak in front of you and your imager battery is dead or your phone's is too low to operate the light. The plug-in imagers in particular have a pretty short battery life, so get in the habit of keeping your thermal imager and phone batteries well charged. I recommend also having a power bank or juice pack on hand as well, like the Cirrus fog puffer. Tip number 3 is focus on insulated supply ducts. Thermal imaging relies on there being a temperature difference between the air leak and the surrounding duct surfaces. So it works best to show hot or cold conditioned air leaking out of insulated supply ducts. Turn on the heat or AC and the air leaking out usually shows up great against the insulated outer surface of the ducts. While it is most dramatic when the leaks are significant, it's always worth seeing if anything shows up, even when the leaks are much smaller and more diffuse. Here's a shot of some wrapped leaky metal ducts near Boston. Notice that the entire jacket of the ductwork is glowing warm, not just where the leaks are. In this case, it happened very quickly after turning on the furnace, and I suspect it's because the escaping warm air is being pushed through the porous fiberglass. Since insulation performance depends on trapping still air, another benefit of duct sealing can sometimes be that you'll restore lost R value as well. Tip number 4 is don't bother scanning uninsulated metal supply ducts. Unfortunately, thermal imaging just doesn't work very well on ducts like we see in most basements because the duct surface is pretty much the same temperature as the escaping conditioned air. There's still probably duct leakage, just not enough contrast. Now, sometimes it is possible for an experienced operator to make out the leakage, but in my experience, the homeowner isn't usually as shocked by the low contrast image, so it just doesn't forward the action. With bare sheet metal ducts, I focus more on just showing the gaps and holes, and often also using a fog puffer. Now, one use of thermal imaging with this kind of uninsulated ducts is to help explain the benefit of adding duct wrap. I've often bundled in some basement supply duct insulation with AeroSeal, sometimes just for the long supply branch duct going to a problem room. Their air will come out a bit colder in the summer and warmer in the winter, helping achieve the client's desired outcome. Tip number 5 is don't bother scanning insulated return ducts. Thermal imaging won't show duct leakage going into insulated return ducts, since the insulation masks what's happening when unconditioned air gets sucked into the airstream inside the duct. To show air getting sucked into insulated return ducts, you need to use handheld fog. So, thermal imaging won't show you the effect of air getting sucked into insulated return ducts. On the other hand, tip number 6 is scan uninsulated return wall cavities. Wall cavity returns covered in drywall often have significant air leakage leading up into the attic. Usually the top plates have cracks and wiring holes. Sometimes the top plate is totally missing or bypassed. If the attic is cold or hot, with the air handler circulating fan on, you can sometimes see the drywall change color as attic air is sucked down. Drywall has no real resistance to heat transfer. Here's a wintertime example in a basement-style house in Kansas City. The purple pattern is from cold air chilling the backside of the drywall as it is being sucked down from the attic. Here's an example of what you might see if the return wall cavity is wide open to a hot attic. Now, since the attic air has to be hotter or colder than the house air for a color change to occur, the results depend on the outdoor conditions and time of day. You could have leakage, but thermal imaging wouldn't necessarily show it at the time of your inspection. One way to magnify the effect for your demonstration is to throw a piece of newspaper or tape over the return grill. That increases the suction in that wall cavity and therefore on the attic leaks, and will often lead to a faster response and a more impressive image. Also, if the temperature difference is relatively low, if you give the drywall longer to change temperature, you're more likely to get a good image. It doesn't have an R value, but it does have thermal mass. On the issue of getting a good temperature difference to create maximum contrast, tip number 7 is choose the best HVAC mode for the greatest temperature difference. Now, usually this means if it's summer and the exterior of the attic ductwork is hot, turn on the AC, in which case the cold air leaking out shows up blue. If it's winter and the attic is cold, turn on the heat and the leaks show up orange. But sometimes you might choose an HVAC mode that is the opposite of what the season would dictate. I've occasionally turned on the heat in the summer when looking for duct leaks in a cool crawl space. Escaping 120-degree air is over 50 degrees warmer than the crawl space. That creates much more contrast than the only 10-degree delta T that would have happened with the AC air leaking out. Here's a challenge. What do you do if the HVAC equipment isn't working? Say if you're on a crisis call. Well, to use thermal imaging to find duct leaks, you need to be able to move air through the ducts and create a pressure. So if the indoor circulating fan motor is burnt out, you're pretty much out of luck. But a pretty common scenario is actually that their heat exchanger's been condemned or their AC compressor is dead. In that case, here's tip number 8 that sometimes works. Just circulate the house ambient air. Here's some photos of a hot Nevada attic where the blue spots clearly indicate duct leakage. But the AC is not actually on. If you look at the spot temperature reading in this close-up, you can see the air leaking out is at 72.6 degrees. It would have been more like 52 degrees if the AC were on. Okay, so that's all we'll cover today. To recap, these first 8 tips are: 1. Get the right imager. 2. Always charge the battery between calls. 3. Focus on insulated supply ducts. 4. Don't bother scanning uninsulated metal supply ducts. 5. Don't bother scanning insulated return ducts. 6. Do scan uninsulated return wall cavities. 7. Choose the best HVAC mode for the greatest temperature difference. And 8. If you can't generate heating or cooling, just circulate the house ambient air. In our next lesson, part 2, I'll share 8 more valuable tips on how to get the most persuasive thermal imagers of duct leakage. Thanks for investing the time to learn how to make the invisible visible. Now, get out and start using your thermal imager, and we'll see you on the next lesson.